Today we're going to talk about radical expressions. But we're going to talk about adding and subtracting. Alright. Now, one thing that you have to understand, in order to add or subtract radical expressions, terms must be like. Alright? The terms must be like. In other words, must have the same radicand. So that part under the radical must be the same.
Now, the first thing we need to review is a like term. For instance, 3x squared, 4x squared, 3x. Are all three of these like terms? Nope, they're not. Are some of them like terms? Which ones? How you know? Huh? That's right. While all of them have x's, they're not like terms unless they have the same variable and exactly the same exponents. So these terms are like terms. Now, if I were to put a plus sign between them and I said simplify, what do I mean? I will combine the like terms, just like Ms. Trinity said. So the way I teach how to combine like terms is this. Write down your first term, which is 3x squared. Then you write down your another. If you found another x squared, you put it right under here, right on more vertically. I have no more x squares, so I put the 3x to the side. Underline means combine. You only combine the coefficient. 3 plus 4 is what? 7, and bring down your x squared. And then you bring down your 3x because it can combine with anybody. And what sign go between both of those because he's positive? Addition. That's combining like terms. All right? Now, adding and subtracting radical expressions, same thing. For instance, if the problem was 3 square root of 2 plus 4 square root of 2, these are like radicals. Like radicals are terms that have the same index and the same radicand. So it's just like that. Like terms are terms that have the same variables with exactly the same exponent. Like radicals have the same radicand with exactly the same index. So if I did this, plus 3 square root 3. All right? Same problem. You treat radicals as the same way you would do variables. You can't combine variables when you add and subtract, when you combine it like terms. We line them up. 3 square root of 2. Do we have another square root of 2 anywhere? They have 4 square root of 2. And he's just going to end because he doesn't have a like term. Underline mean combine. 3 plus 4 is what? 7, and bring down your radical. Bring it down. Then you bring this down. 3 square root of 3. And because it's positive, what operation? Addition. Same problem. So let me give you that definition of like radical terms. All right. Like radical. Like radical terms. These have the same radicand with exactly the same index. I didn't say coefficient had to be the same. Radicand and index. Now,
we got two sets of rules. If radicands are the same, Rule 1. Combine the coefficients. Combine the coefficient. S. Combine all the coefficients. Rule 2. Simplify the answer. Now, if radicands are different, first thing you do is simplify. You simplify the radicals to make them smaller. Alright? Make them smaller. And then combine like radicands. Like combine only like terms. Alright? You do this by combining the coefficients. Alright? Because once the radicands are the same, we're over here. Alright? We're back to here. Alright? So you combine the like terms.
Let's try 2 negative 2 to the 20 minus 2 to the square root 2 square root 5. Sorry. Negative 2 square root 20 minus 2 square root 5. Now, first thing, check for like radical terms. Are these like radical terms? Nope. So if not, simplify the radical. So 5 is cool. We can't break that down. We can break down 20. 20 is what times what? What you using? 5 and 4, or 2 and 10, same thing. But 4 can break down to 2 times 2. All right, let's cross out that 4 so we won't use it. Now, do you have 2 of anything? Because that's what the index says. You got 2 2's. So a 2 would come out and join that negative 2. What's 2 times negative 2? Negative 4. What factor is left over? All right, and then I bring this side down. We can't break that down. We're good. Now, let's go back. Now, do you have like radicals? Yeah, so now that we do, now we line them bad boys up. We say negative 4 square root of 5, negative 2 square root of 5. Underline mean put a plus sign. If you use a calculator, just put a plus sign between them. It mean combine. Put a plus sign between them. Negative 4 plus negative 2 is what kind of 6? Negative 6, and bring that square root of 5 down. That's the answer. All right, let's do it again. Let's do it again. All right, so let's try. Let's start off like 2 square root of 5 plus 3 square root of 5. All right, first rule says, isn't that glare? Check for like radicals. Are they like radicals? Yeah. Both of them got square root of 5, square root of 5. So line them up. 2 square root of 5, 3 square root of 5, and I combine that, I get 5 square root of 5. And I can't break that down.
Now, it's a problem. 5 square root of 8 plus 2 square root of 8. Alright? These radicands are the same. Square root of 8, square root of 8. So I just combine the 5 and the 2. So that's 5 plus 2, radicand of 8. 5 plus 2 is 7. And bring the radicand along. Alright? Now, let's simplify. Let's see what we can pull out. 8 can be factored down to 2 times 4. And 4 is 2 times 2. Remember, every time we have 2 or something, it comes out. So a 2 comes out. And you multiply everything to the outside. So our final answer is 14. Do you have anything left on the radical? Yes. 14 square root of 2. Alright, you can't say 4 because we broke the 4 down. You can't use the 4. It's like me giving you change for a $10 bill. I will not be giving you the $10 bill back. We broke it down. So if need be, you can scratch it out if you break it down. So you won't use it again. Whatever you need to do. Alright, let's do another one. Another one would be -4 square root of 5 plus 5 square root of 5. Alright? Are the radicands the same? Yes, both of them square root of 5. So we just combine -4 and 5. We can't add them because one is negative, one is positive. So we get -4 plus 5 square root of 5, and we get, both of them go together, right? We get a 1 square root of 5. 5 can't be factored, so we're good. Let's keep going. Alright, let's do another one. Let's do one where the radicands are different. So if we have square root of 54 plus 2 square root of 24. Alright? 54 breaks down. So remember, the radicands are not the same. So we can't put them together. So let's try to make them smaller. So 54, one way to get 54 is 9 times 6. And 9 breaks down to 3 times 3. And 6 breaks down to 2 times 3. For everything we have 2 of, that factor comes out. We found 2 3s, so a 3 comes out. We don't have 2 of anything else. Alright, so for 24, we do 6 times 4. 6 is 2 times 3, 4 is 2 times 2. Alright, we have found 2 of something, which is instead of 2. So a 2 come out to be with this one. So remember, if you already have someone out there, you just multiply everything that's out there. So that's 2 times 2. Alright, so anyway, with this set of problems, we have a 3 that came out here, and 2 times 3 is left under the radical, so we just put it back together and get 6. For this one, a 2 came out, but there was a 2 already out there. That's 4. And what's left over? A 3 times 2, which is 6. Remember, you can't tell me a 6 and a 4 was left over if I gave you change. Right? If I give you change, you're not getting your $4 bill or your $6 bill back. It's already down. And we'll use it. So 3 and 2 goes back together to make 6. There's a plus sign between these numbers. Fine. Cool. So now we have like radicand. So we put the 3 and the 4 together, which is they belong to square root of 6, and the answer is 7. Square root of 6. Alright, let's do another like one. That looks kind of different. Alright. This one is 2 square root of 10x plus 8 square root of 10x. Alright, the x is underneath the radical. So you have 10x as a radicand. Are they the same? Yes. So you just combine the coefficient, which is 2 plus 8. Alright. And they both have 10 square root of x. So the answer is 10 square root of 10x. If I try to break 10 down, I get 2 times 5. I won't get 2 of everything. 2 of anything, I should say. So that's your final answer. That's how you add or subtract radical expression. What if you had a problem? That problem said 5 square root of 2x squared minus 2 square root of 200. Let me do this before we go. Now, they are not alike. So we have to simplify the radicands. We gotta make them smaller. See what we can do. Alright? 2 is just 2. It won't factor. But I have 2 x's here. And the index said everything I have 2 of, that comes out. So if you can't see it like 2 divided by 2, I told you can also spell them out. X squared is 2 x's. I found 2 of something, so that x can come out. So that leaves 5x square root of 2. Because the coefficient 2 couldn't be factored, so we had to leave it in there. Both x's, a pair of x's came out, so we got 5x. 200. In order to get 200, you can do what? You can do 20 and 10. You can do 2 times 100, 4 times 50. Just whatever factor you want to use. Now 20 is 5 and 4. 10 is 2 and 5. 4 is 2 times 2. Alright, everything we have two of, we can pull out. We have 2 5, so a 5 comes out. We have 2 2s, so a 2 comes out. So remember, everything you pull out is multiplied together. So for this particular term, we have 2 times 2 is 4, 4 times 5 is 20, and we have minus 20, and what's left in the radical? Let's look really close. You can't leave anything out. Everything we had at the tip was circled except for that square root of 2. So let's put it back close together. We have 5x square root of 2 minus 20 square root of 2. Alright, now, do they have the same radicand? Yes. However, they are not like terms. Radicands are the same, but when you see a variable, they also must have the same variable to be like terms. If that was 20x, yeah, negative 15x square root 2. But that's not the same term. So here we have to check radicands and the variable. Not like terms. So this is your final answer. Alright? Make sure you practice.
3, 5, and 7.